All right, so we're doing 11-2. So we got to start by talking about the shapes that we are learning about today. So the first shape is a prism. A prism is a polyhedron, and a polyhedron is a word I taught you yesterday. It's a 3D shape made up of polygons. And there are two parallel faces in a prism, and they are called the bases. So a face is just any like side of the shape. A base is the two ones that are parallel and congruent. They are congruent polygons. The other faces are what we call lateral faces. Lateral, lateral faces. And in a right prism, then those are all going to be rectangles. I think a good example of this is like a tissue box. My bases are like the squares that are the ends of the tissue box. I've got two, one on each side. And then the other four are all rectangles that connect my bases together. Okay. The altitude or the height of a prism is the perpendicular distance. Perpendicular distance between its bases. So I drew a little like upside down T. That's our perpendicular sign. Don't make it any harder than it is. It's just the distance between one base to the other base. Just if there's any slanted distance or like diagonal distance, we don't get to count those. So I've got two examples right here. The first one, I've got these like square bases, kind of like that tissue box I was just holding up. And then the height is the distance from one base to the other. It's the entire length of one of the lateral faces. The lateral faces are those rectangles that are blue. So that's called a right rectangular prism. The other shape, those bases are pentagons. So we call that a pentagonal prism. A pentagonal prism. Prisms are named by the shape of their bases. So like the first one, I said it's a square. I guess they decided that's a rectangle. So those bases are rectangle. Hence, it's called a rectangular prism. The second one I just talked about was a pentagon was my base. So that's a pentagonal prism. The other common one we do is a triangular prism, and we'll do an example of that in a second. All right, so I've got a diagram below. You can assume angles that look like they're right are right. What shape is each base? What's the shape of these bases here? What was it? Hexagon. Very good. It's a hexagon. 6 sides, hexagon. So we're going to call it a hexagonal prism. We good? Like I missed a joke. You just have a squeaky chair, Colin? Not you? Okay. I feel crazy in this class. I like you guys so much, but you guys make me feel crazy. All right, what shape is each lateral face? What are the non-hexagonal shapes? What are those called? Don't make it harder than it is. Rectangles. It's just a rectangle. And then it says, name the segment whose length is the height of the prism. There's a lot of options. Who can name one segment that's the height of this prism? Megan? FL works. Anything that goes from one hexagon to the other. AG, BH, CI, DG, EK. Megan said FL, so we're going to write FL, not FJ. I don't know why I wrote that. And let's write a little segment line over it because it's a segment. Okay, next. For both of these shapes, we're essentially using these formulas. In both of these, we have to do 3 things first. We have to identify the height of the prism. There's really usually not any math there. We just have to find it on the picture. Then we have to find the perimeter of the base. So if we were doing the example above, we'd have to find the perimeter of this hexagon. And then we'd have to find the area of that base. We find those 3 things because that helps us find everything else. Lateral area, surface area, and volume. Lateral area is the area of its lateral sides, lateral faces. Lateral area is like if I was doing the area of this tissue box, but I didn't do the bases. So I'm just doing the area of these 4 rectangles. That's what the lateral area would be. To do that, we need to take the perimeter of the base and multiply it by the height of the prism. Using my abbreviations above, perimeter of the base is the same thing as big P. Height of the prism is little h. Okay. We do lateral area first because that helps us find the total surface area. Surface area is going to be my lateral area plus 2 times B, 2 times my base. Excuse me, 2 times the area of my base, not just the base. Again, lateral area on this tissue box is the area of these 4 rectangles. And then the one base is here, the other base is here. So we have to do 2 times the area of the bases. All right, and then last is volume. Volume, if you remember back from like elementary school, you've done volume before, which is just length times width times height. Think about how length and width go together. That's the same thing as the area. So we're gonna do area of the bases. And then height is all by itself. And then we're gonna multiply it by height of the prism. And so that in small letters would be big H, or big B, excuse me, and little h. All right. Anybody questions yet? All right, let's do a couple examples. So first thing we're going to do before we do anything else is find height, big P, and big B. Once we find those, then we're just going to multiply those or add or whatever those together to do LA, SA, and V. Okay, what shape are the bases in this new example? What are my bases here? Triangles. What's the height of this prism? 8. Good. It's the distance between the triangles. It's not like a vertical height always. It's just the distance between the bases. So 8 inches. I'm going to highlight that yellow because I'm going to need that later. Okay. Now we got to do perimeter of the bases. How do I find the perimeter? I see this is 6 and I see this is 6. What's this side? 6. I know it's not written next to it, but they're congruent triangles, so this has to also be 6. 6 plus 6 plus 6, or 3 times 6 is 18. My perimeter of my base is 18 inches. And then last I have to do base area, and I'm actually gonna have to do a little bit of like outside work for this. Let me redraw my base. My base is this equilateral triangle, 6, 6, 6. The whole reason we spent yesterday going over 2 days ago, sorry, was it just yesterday? The reason we spent 2 days ago going over these special right triangles is because you got to use them here too. I'm going to drop my perpendicular, drop my altitude. I now have 2 small 30, 60, 90 degree triangles. Anyone know what this distance when I cut that bottom in half is? 3. And then what's my height of this whole shape going to be? What do I multiply by the short side to get the long leg? Radical 3. So my height is 3 radical 3. Remember we did that a lot yesterday? We're going to keep doing that. So my area here is 1/2 base, which is 6, times height, which is 3 root 3. Again, just like I said yesterday, remember to do the entire base. 6. 1/2 of 6 is 3, and then 3 times 3 root 3 is 9 root 3. And it's area, so that's inches squared. Okay. Once you find these three things, it's super easy to find the rest of it. We just got to plug them into the little formulas I gave you above. So for example, the first one we're going to do is LA. I told you that that's P times H. So I'm going to do P times H. P is 18, H is 8. P times H, 18 times 8 is 144 inches squared. Everyone okay so far? Surface area is LA plus 2B. Well, good thing I just found LA. It's going to be 144 plus 2 times whatever B was, and B was 9 root 3. So I'm going to do 2 times 9 root 3. Now, I cannot add 144 plus this other term because the other term has a root 3, but I can do 9 times 2 and get 18. So I'm going to do 144 plus 18 root 3. That's my best answer. Throw some units on it, inches squared. Last thing is volume. Volume is B times H. I do 9 root 3 times 8. B times H, 9 root 3 times H, which is 8. 9 times 8 is 72, so I got 72 root 3. And volume is always cubic units. So it's inches cubed, miles cubed, feet cubed, kilometers cubed. I don't care what it is. Okay? Why don't you flip your paper over? Why don't you try the next one? I'm going to leave my work up here, but I want you to try it. At least identify H, P, and B. I'm going to be quiet for a minute, and I'm going to jump in and finish that example for you. Okay, finish up where you're at. If you're doing great, keep moving. I'm just going to pipe in case anyone is a little lost, or just so you can check your work. So here my bases are trapezoids. Now height, be careful. It's not my slant height, it's always the perpendicular height. So my height here is 6 centimeters. Make sure you have your height right. Questions on that? Okay. My perimeter is just adding up all my sides. If this is my trapezoid, oh God, that was so bad it made it a rectangle. Okay, only slightly tragic. One of my bases is 12, one is 6, and then these slant sides are both 3 root 5. So my perimeter is going to be 6 plus 12 plus 3 root 5 plus 3 root 5. 6 plus 12 plus 3 root 5 plus 3 root 5. You can add 6 and 12 together to be 18. And you can add 3 root 5 together plus 3 root 5, and I get 6 root 5, and that's centimeters. That's as simple as my perimeter gets. Everyone okay with that? And then my area of my base, remember area of a trapezoid is 1/2 height, which is 6. Oh shoot, I messed something up. What did I mess up? Did anyone have a different height? It is 4. What was I thinking? I thought Megan gave me a weird look when I wrote 6. Oh, maybe you didn't give me a weird look. I thought somebody gave me a weird look. I thought it was you. Okay, let's talk about that. Height. I want us to be careful. Height of the trapezoid is 6. Height of the entire prism is 4. Because remember, height is the distance between one base to another base. So as I was about to do height for my trapezoid, that's when I realized, oh, that's not the right height that I wrote earlier. Wow, I'm so glad I made that mistake so you don't have to later. We got to share mistakes. Sometimes I got to make them, sometimes you got to make them. Okay, so I have to do 1/2 of 6 times, and this time it's 6 plus 12. Base 1 plus base 2. 1/2 of 6 is 3. 3 times 18, I believe, is 54. So my area of my base is 54 centimeters squared. Is that 4 too? No, because I'm looking at the area of the trapezoid. Good question, though. It's so confusing because there's so many heights, there's so many bases, there's so many things. So yeah, so this one is 6. I'm convinced on that one. The other one was 4. Okay, now we're going to do LA, SA, and V. I'm going to kind of rush through those a little quickly. So LA, remember, is PH. So P was 18 plus 6 root 5. And then H was 4. So we got to distribute 4 to 18 and 6 root 5. 18 times 4 is 72, I believe. Let me double check. Oh, shoot. Oh, shoot. What did I do with that? We'll figure that out later. Let me get my calculator. Maybe if I was just a math teacher with a calculator, that'd be better. But 72, and then 4 times 6 root 5 is going to be 24 root 5. And then I put that as centimeters squared. I cannot simplify that anymore. Everyone okay? Did I mess that up yet? Okay. SA is going to be LA plus 2 times B. So it's going to be 72 plus 24 root 5 plus 2 times B, which was 54. Once I do 2 times 54, I'm going to be able to add that to my 72. All right, 2 times 54 is 108. 108 plus 72, I believe, is 180, right? So I get 180, I could write my numbers, plus 24 root 5 centimeters squared. And then last, V is B times H, which is 54 times 4. 216. Again, volume's always cubed. Now, I didn't have time to do this last hour because of math. I truly think I did this wrong for A period. So A period, if you're watching, I'm really sorry. I'm looking at these numbers. I really think I put height with 6. So I'm apologize here publicly. Yikes. All right, let's do cylinders. Cylinders are very, very similar. They are just not polyhedrons. They are not polyhedrons because they have circles as their bases. The height of the cylinder is just the distance between those circular bases. And the radius of the cylinder is the same thing as the radius of the circle base. So what's nice about cylinders is we're just using area and perimeter for circles. So the area of a circle is going to be pi r squared. And then my perimeter or my circumference, you can call it either one, of my base is going to be 2 pi r. or pi d. You can use whichever one you want. Now, the funny thing about this with a cylinder, I like to think of it like a can of soup or a can of beans or a can of tomatoes or a can of whatever you have. When you have a can of anything, it has a nice little label on it, right? Because you got to scan it at the grocery store so that you buy it, right? I've got this nice little label. If you cut the label off your can of soup, it unfolds to be this nice rectangle. So my lateral area is just the area of this rectangle that comes as my label around my soup. One of the sides is the height of my cylinder. So like this is the height, which is this like short distance when I unravel it. The top though comes from when it's all rolled up, it's my circumference of that circle. So one of my sides is the circumference or perimeter, and then one side is the height. So that's what I'm kind of getting at. So lateral area is the area of the unrolled rectangle. The length of the rectangle is the perimeter, or again, you can think of it as circumference if that makes you happy, of the circular base, and times the height of the cylinder, which is still P times H. Oh, the blank I forgot is a rectangle. I said that word and then I didn't write it in. When you unroll that paper label, it becomes a rectangle. Surface area is the exact same thing as it was before. It's just 2B plus LA. Remember that LA is at pH. And then base is pi r squared. You can even break P apart to be 2 pi r h. And then volume is still big B times H, but remember big B can be pi r squared H. Now, I think it's more confusing to break it apart with the pi's and the r's and the squares and the twos. I just am going to keep using the ones we've used. B times H, 2B plus LA, PH. You are welcome to do the pi r squares, etc., but we're going to do that separately and then we're going to put it in here. Okay? So let's go to the back page. I really would love to get through these two examples if I can. I can go back. Is that good? Ooh. What do you want to see? Okay. I have, this says pH. This says pi r squared. The one next to it says 2 pi r h. And then the one under that is pi r squared h. Awesome. Okay. So let's do these two examples. The first one, okay, what's my radius of this picture? 4. Let's put units with everything. So I'm going to say 4 meters. What's the height of this cylinder? I think I heard 5. Remember, perimeter is your circumference. So perimeter is going to be 2 pi r. In this case, that is 2 pi 4, which is 8 pi meters. The next one, big B, is the area of my base, which is pi r squared. Pi r squared is going to be pi 4 squared, which is 16 pi. And since it's area, it's meters squared. So take a second, make sure, bless you, make sure you have all 3 of these. Make sure you understand how I got them or you got them. Anybody have any questions on these 3? Okay. The reason I always pause after these 3 is I have to use them for everything else. So if you don't have the height right or the base right, then it's going to be a long rest of the problem for you. All right, so LA, reminder, LA is P times H. So I'm just going to take my P, which is 8 pi, times H, which is 5. So 8 pi times 5, it's going to be 40 pi meters squared. SA is LA plus 2B. It's actually kind of fun on cylinders because I can combine SA to just be one term. It's not going to be two separate terms. I'm going to be able to combine it all the way down. So LA was just 40 pi, and then 2 times big B, which is 16 pi. 2 times 16 is 32. And then 40 plus 32 is 72 pi meters squared. Last thing is volume, which is B times H. B is 16 pi, H is 5. 16 times 5 is 80 pi. Remember, volume is always meters cubed. Okay. All right. All right, I'm going to be quiet for a second. We still have 5 more minutes, so I want you to try the next one, and I'm going to finish it up with you in 1 second, okay? Anybody questions yet? All right, go right ahead. I'm going to be quiet so you guys can still work, but if you want to see, I'm going to have the answers up on the screen. So if you're on Zoom or on YouTube, just you can watch, but I'm going to be quiet still. Check in if you haven't already. Make sure your height, your perimeter, and your base are all the same as mine. Anybody get a different answer and want to check in why? All right, you're all just moving and grooving. Great. Ooh, don't lose your pie like I almost did. Always bring pie with you. All right, guys, I've got my LA, my SA, and my V all up now too. Anybody have any questions, differences, concerns? All right. We made great time with this lesson. I hope I didn't hustle too much for you, but it's now recorded so you can go back and watch it later. Reminder, your homework is online. It's just a one-sider, 11-2, 11-4. And when I see you on Friday, we're going to do 11-3 and 11-5. Cool. Anybody questions? All right, let me stop my record.